Hello everyone, Yellow Mustang here once again with another Roblox scripting tutorial. That is right, we're finally doing another scripting tutorial. It's been a while. I got a request on how to control like multiple NPCs using one script to kind of clean things up and consolidate scripts, I guess, into one and get some better performance out of your NPCs as well. And to do that, we're going to be using the collection service today. So for those of you who don't know what the collection service is, it's basically like a tagging system where you tag different instances in your game, and then you can later reference those instances fairly easily. So here I got some zombies. And then I'm using a plugin over here, the tag window, tag editor plugin that everybody uses. I'll link this in the description. This isn't required, but this helps to actually visualize the tags and see what is tagged exactly, because without this you won't know what is tagged. So you can see here, if we click our humanoid, it says we got the zombie tag on it. If we click anything else, nothing else is tagged, so we got the humanoid tagged. I'll go ahead and import this and just delete it. And I'll just show you guys how I tagged it. So if you don't want to get the plugin, you can just do it through the command bar here, or what is this damn thing called? It's the oh god, it's gonna bother me now. What is this? Yeah, the command bar. Oh shit, I was right. Okay, yeah, the command bar. All right, so we're gonna do like game, get service, collection service, and then yeah, so we're gonna do collection service, add tag, and then we specify what instance we want to tag. So in this case, we're going to be tagging the zombie humanoid, and then we tell it what we want the tag name to be on it, and we're just going to tag it zombie. Boom, bada bing, bada boom. This didn't refresh, so if we click off of it and then click back on, you can see now the humanoid is tagged with zombie. So now we can easily reference this zombie. And then if we duplicate this guy a couple times, you will see all these guys with the humanoid will have the zombie tag. So that way we can easily reference all the zombies humanoids and make them like Pathfind or whatever, or move around the workspace easily without having to put them in a folder or something. They just can be floating wherever you want, and then we can reference them. Okay, so that was a very long-winded explanation. Hopefully that made sense. Let's get into some actual scripting here. So server script service, we're going to create a new server script. We'll just call it zombie handler, I guess is fine. And first thing we're going to do is create a reference to the collection service. So there we go, we got the collection service there. Then we're going to specify a table for our zombies. So we're going to go ahead and put all the alive zombies in this table. Next I'm going to create a function so I can easily create new threads within my script using quarantines. So this is going to basically just, whenever we want to create a function on a new thread, we're going to call spawner. I call it spawner because it's similar to spawn. You don't have to call it spawner, you can call it whatever you want, but I just use it to create new quarantine threads. Yeah, you don't have to do it that way. Okay, so let's get started here. So first off, we're going to start kind of like at the bottom of the script and work our way up. The first thing we're going to do is the tag management. So we're going to do function tag human instance. We'll do local human equals instance find first child humanoid. So we're going to search the instance for the humanoid class. And it won't matter what the humanoid is named, it will just find it as long as it contains a humanoid class instance in there. So if human actually exists in the instance, then we're going to tag it. So we're going to do collection service, add tag, human, and we're going to name it human. So this is just going to tag humanoids as we see fit, so we don't have to like loop through the workspace. We could just loop through our list of humans to see what target, basically. Okay, so continuing on here, we're going to create the remove zombie function. And then call it zombie. Do local index equals table.find zombies zombie. Table.remove zombies index. Wait 5. Zombie.care destroy. Zombie.clone.parent equals workspace. Okay, so basically what this function is doing is handling the zombie respawning. So this is going to be called when one of our zombies dies. We're going to remove it from our zombies table. And we're going to find the index of the zombie just by searching the table for our zombie value there. And then it's going to tell us what index, and then we can just remove whatever index in the table. And wait 5 seconds, destroy the zombie out of the workspace, and then we're going to clone the zombie into the workspace once again. Okay, so that'll make sense here in a minute. So we create the next function here. We're going to call add zombie. Zombie humanoid. Cool. So this is going to be called when we are adding a zombie to our zombies table. So we're going to do table.insert to add it to our table, and we're going to be inserting it into the zombies. And then we're going to be inserting a table inside of our table. So I believe you would call this a dictionary table, I guess. So we'll do care equals zombie humanoid dot parent. Because that's going to be the character for the zombie. Then we're going to do root equals zombie humanoid dot root part. Human equals zombie humanoid, obviously. And then target equals nil, which is going to keep track of what target that zombie is currently on. And then we'll do clone equals zombie humanoid parent clone. And then we're going to do the grab animation. Or just grab anim. We'll load the animation into the humanoid there. Do zombie humanoid parent.grab. And that's just our simple attack animation that we have already inside of the zombie. Okay, and that should be good for that. Next, we're going to initialize the zombie. So we're going to do for underscore zombie in pairs. Zombies do. So basically we're looping through all of our alive zombies here. And then whatever zombie we're on, we're just going to have that be the zombie value to keep things simple there. So we're going to do zombie. If zombie.human is equal to zombie.humanoid, then continue. So basically what we're doing here is figuring out the table reference to wherever we just inserted that zombie. So we're basically just pulling this table here, and we're going to pass it on is all we're doing. So now we're going to create a anonymous event here using the humanoid died event. So we're going to keep track of if the zombie in our table dies. So zombie.human.die connect function remove zombie, and then pass it the zombie dictionary table thing. So that will pass it up to here. It's going to find the index, clear it from our table, and then perform the respawn on it, essentially. And that will happen instantly since we got it tied to this event here, so that'll keep our table cleared out of zombies that are already dead. Will save us resources. Continuing on, we do 4IV in pairs. Zombie.care. Get descendants. Do. If V is a base part. And V can set network ownership. Then continue. V set network owner to nil. Okay, so basically this is looping through all of the parts of our new zombie and setting the network owner to nil to ensure that the server has control of the zombie 100%, so the pathfinding isn't laggy or any of that nonsense. Next thing we need to do is use our spawner function here, and we're going to reference the movement handler and pass it zombie. And this is going to come up red for now because we haven't created that function yet. Then we'll put a break after that. So essentially, we are going to have each zombie on their own pathfinding thread, because pathfinding delays a loop, so we have to have every zombie on their own thread for the pathfinding at least. So yeah, that's why I did that. Continuing on here, we're going to do workspace.child added, connect, tag human. So whenever an NPC responds in the workspace, it's going to, well, I guess whenever anything is added to the workspace, it's going to check it for a humanoid. If it contains a humanoid, then it will go ahead and tag it as human, so we can easily check and see if it's close enough for us to attack or not. Next thing we're going to do here is do collection service, get instance added signal, zombie, connect function zombie humanoid. Then we do add zombie humanoid. Okay, so this is using the collection service once again, and it's going to fire whenever a zombie tag is added to our list of zombie tags, kind of like child added, but tag form. And then it's going to pass along the zombie humanoid, and then we're going to go ahead and initialize it into our zombies table there. So continuing on here, we're going to create the initialize function that's going to run one time just to get everything set up. Initialize. Hopefully that's spelled right. Anyways, so we're going to do 4_v in pairs. Collection service. Get tagged. Zombie. Do. So we're going to go ahead and loop through everything that is tagged zombie just to ensure that it's in our table. So we'll do local found is false. We're going to flip this boolean if we do end up finding the zombie in our table or not. So we'll do 4_x in pairs zombies do if x dot human is equal to v, then found equals true. So we are going to loop through all the zombies and then loop through all of the zombies in our current alive zombies table. And then when we're going through the table, if we find the humanoid is already in our alive zombies table, then we'll just go ahead and flip this boolean to true. So that way we know it's already there, so we don't have to add it. So we'll do if not found, then add zombie v. So all we're doing is just sending over the humanoid passed over from the zombie tag, and then we'll add it to our initializer here essentially, so we can do cool stuff with it. And then at the very bottom of our script here, we're just going to call initialize. So this will just run one time because since our zombies are already tagged as zombies and they're already in the workspace, sometimes this workspace, let's see, Yeah, this actually. Sometimes this doesn't fire reliably for everything, so I just have this initialize here to double check and make sure that all the zombies get tagged when the game is first run. So that's all we need to do really with the collection service. At least now we need to set up the AI moving portion of the zombie. So we're going to come up here and we're going to set up our typical check distance function. If you've seen my videos before, you know how fond I am of using check dist because it saves so much space. So we're going to do if type of part1 is not equal to vector3, then part1 equals part1 dot position end if type of. Okay, so the way I have this function set up is I can send it over a part instance or a vector3, and it's just going to go ahead and sort it out for me using type of. So we're going to detect if it's a vector3 value. If it's not a vector3 value, then it's going to be a part. If it's a part, then we're going to go ahead and just pull the position from the part and just update the variable with that position. So it's fairly simple there. And then we're just going to return the magnitude difference between the two parts, essentially. Magnitude. Okay, there we go. So simple enough, you know. 5 lines saves us a lot of time there. So continuing on here, we're going to create the update target function for our zombies so they can find, you know, their target in the workspace that they can go after. So we do local. So here in humans, we're going to pull everything that is tagged human that we tagged below here. So that way we don't have to loop through each part in the workspace. You know, we can just tag through the human specifically, which is much more efficient. Now we'll do for underscore zombie pairs zombies do. We'll do local target equals nil. Local dist equals 200. So for underscore zombie and pair zombies do, this is just looping through all of our alive zombies. So we can just update the targets for all of our zombies all at once, all in one while loop essentially. So we'll set the target to nil and then dist to 200. So this will be like the detection range there. Then we'll do for underscore human in pairs humans do. So then we'll go ahead and loop through all the humanoids there, and we'll do local root equals human dot root part. And yeah, so then we'll check if the root part exists and the human is alive. And then we'll check the distance. It's less than dist. So just make sure, you know, the distance between our root part and the zombie root part is below the distance, so it's close enough. And then we're going to make sure that they don't have the same name as us. So we'll do and human.parent.name is not equal to zombie.character.name. Then continue. Okay, so that's fairly easy there. Then we're going to go ahead and update the distance. Okay, there you go. And then target variable, we'll go ahead and update with the root. And then there you go. All good. So we got the target now, which will contain the humanoid root part of the closest target to us. And then we're just going to go ahead and update the, we'll tell the zombie that basically. So we're going to do zombie dot target is equal to target. So there we go. Then the zombie will be able to pathfind it to it hypothetically, and then we can reference this target as many times as we need to get the zombie over to attack properly. So that's all we need for the update target. Now let's go ahead and create a loop to actually handle the updating. So we'll just update every 1 second. And there we go. So we're gonna just spawn a new thread for this while loop so it doesn't, halt our script or whatever. I guess, yeah, so that way we can have multiple while loops running at once, is the way I kind of break up my scripts now since I've, gotten more into multi-threading, I guess. Now we'll go ahead and create the pathfinding function, so we'll do path to target, zombie. Go ahead and get ourselves a path variable created there. Then we'll do the path compute async, starting position, zombie dot root dot position, and then we're going to end position is going to be the zombie dot target dot position, which is going to be like the root part of one of the humans in the workspace. So we'll go ahead and pull the waypoints from that. Okay, and then we'll go ahead and take note of what the current target is. Okay, and that way if the target changes, we can check that and update our pathfinding to path towards the new target. Let's go ahead and loop through the waypoints here. Do if v.action. Okay, so check if he needs to jump or not. And then if it's not jumping, then it's going to be moving. So just do zombie human move to v.position. Cool. Okay. And then we're going to do a double check thing here to see if the zombie needs to jump. So we're going to do spawner on a new thread, wait half a second. Then if. Okay. So this is going to just check like half a second later if the walk to point is above our humanoid root part position. And if it is above our humanoid root part position, then we're just going to go ahead and jump. That's a good way of keeping your guy from getting stuck because they tend to get stuck quite a bit. So I find that helps pretty well. It's pretty simple. So now we're going to do human, zombie.human, move to finished wait. So this is going to go ahead and pause the while loop here until, the zombie gets to the waypoint. So now we will do some checks. Do if not zombie.target, then break. So if there's no target, then we'll just break out of this pathfinding because there's no point in pathfinding to somewhere that doesn't exist, right? Now we'll go ahead and check the dist between our current target and our last waypoint. Yes. Okay, so that will return the magnitude for us, and then if the distance between the current target and our last waypoint is more than 10 studs away, then we're going to probably have to generate a new path because the target has moved. So we want to pathfind towards where the target is, not where the target was. So we'll just keep checking each time to make sure that the target is in the same area roughly. Is a good way of doing that. And then we'll do an or current target is not equal to zombie dot target. Then we will path to target zombie break. So if any of these two conditions are met, then we're going to just call this pathfinding function again. It'll generate a new path towards our new target or whatever. And then once that finishes, we're just going to have a break here so we don't continue with that loop because we are done with that path. Okay, so that's easy enough there. Now we'll go ahead and create that movement function so we can get rid of that nasty red line down below. So movement handler is pretty simple. It's just going to be a while wait one loop. We're going to do if so we will check every 1 second if we need to move, but we're going to break the loop if we are dead, is what that's saying. And then we'll do if zombie.human, or sorry, zombie.target, path to target, zombie. So we'll just go ahead and start the pathfinding for whatever zombie, and this will be running every 1 second, and each zombie will have its own thread of this, so each zombie can pause this function as much as they want so they don't affect the other zombies as they're pathfinding. Hopefully that makes sense. That's the simplest way I found to do that with multiple zombies and the way pathfinding works in Roblox. Works for me, should work for you. So yeah. Next we'll create the attack function. Pass the zombie, whatever zombie is attacking. So do local human. So local human is going to be the target's humanoid, is what that's doing, and then we'll just do human take damage. Mat.random for some randomness, and we'll do 15 to 25 damage is pretty reasonable, I guess. And then we'll just play that zombie dot grab anim, so that way we get a nice little grab effect for our zombie. And then we're going to go ahead and create the loop for our attack checking. So we'll just do while wait every half a second, and we'll just see if we're close enough to our target. And we're going to do this for excuse me. We're going to loop through every zombie and just check and see if they're close enough to their target all in one swoop here. So we'll do for_zombie in pairs. Zombies do. If the zombie has a target, and then if the distance between the zombie target and the zombie root part is less than 8, so they're pretty close, and then we can go ahead and just do the attack motion. All right, there we go. All right, so that was a lot of scripting. I think we should be pretty much good to go. That should work. Let's go ahead and run this and see how many errors we get, I guess, right off the bat. All right, cool. So, of course, position, got a wrongly placed I in there. Go ahead and fix that. Okay, well, that wasn't too bad. Let's see if they can attack. Cool. Okay, they can attack. So let's watch these guys. You can see they're all moving just like they would if they had their own script. You can't really tell that they're operating on their own because all the pathfinding has their own thread, which is good. So you can see they're all attacking, Alvin blocks there. Good old Alvin. And you see they're pathfinding fairly well. Sometimes they will get stuck, but this will time out after like 7 seconds. Which isn't a huge deal. There's ways to fix that, but that is outside the scope of this video. Let's watch these guys for a little bit longer. I just want to make sure the respawning is working okay. I do have a turret over here that I made in Blender. Zombies. What are you doing? This is not my fault. This is Roblox. Roblox is dog shit pathfinding. This never happens unless I'm recording. Okay, so there we go. Go get the turret. Man, these zombies do not want to die today. Okay, so there we go. So that should clear that zombie out after like 5 seconds or so. So it's cleared out, and now you can see over here, they are indeed respawning as if they had their own respawn script and everything. So, there you go. That's basically controlling multiple NPCs with one script there. It's only like about 150 lines of code, 160. And that way we can just go ahead and create as many zombies as we want. I love it when the duplicate thing just doesn't do its job. All right, there we go. Let's get some more zombies in here. Let's see what kind of performance we get with all these boys. See if we can crash my computer. Please crash me. It's actually... it's actually running pretty good, goddamn. All right, well, there you go. We have the true zombie apocalypse here. I don't know what's going on there, but I'm sure they'll figure it out. Damn, I hate scripting tutorials. My throat gets so dry. But yeah, you can see we got like 1 million zombies in here, and it's not killing my game too badly. Performance. It's like script performance. How bad is this doing? Zombie Handler. It's less than 3%, which is actually pretty good for how many zombies we have. So yeah, that's pretty damn efficient. But yeah, you guys can see it's running pretty smooth. But yeah, that's pretty much the tutorial. Hopefully I covered everything pretty good. If you guys enjoyed the video, please drop a like. If you haven't subscribed yet, feel free to join the Yellow Mustang Army of Greatness. Also, we have a Discord server. Link is in the description. And I will see you guys next time.